Dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangare. Let us discuss energies of orbital. And first we have taken that is a single electron system. Single electron system. And single electron system like that the hydrogen atom. The energy of single electron system is proposed by Schrödinger. The energy of electron in nth orbit is equal to minus 1312 into Z square by En square. Now, Z here is nothing but atomic number. Atomic number. And here N is represents principal quantum number. So it is principal quantum number. And according to this equation, the energy of electron depends on that is principal quantum number. When the energy of an electron increases when the principal quantum number increases. So, N value increases, then energy of electron is also increases. So, N value increases, the energy of electron is also increases. It is for single electron system like an hydrogen. So, here order of energy, we may take that N value increases, energies of orbital is also increases. So here 1s has lesser energy than that of 2s, which is equal to 2p, then 3s which is equal to 3p and 3d. Here 4s is equal to 4p and 4d and 4f, and it is 5s which is equal to 5p and 5d and 5f likewise. And we may take here only the N value, and here it is the principal quantum number. The number 1, 2, 3 represents principal quantum number, and this S, P, D and F represents azimuthal quantum number. N value increases, energy of electron is also increases. It is applicable only for single electron system. Multi-electron system. Multi-electron system. And in the case of multi-electron system, that is more than one electron, then we are using N plus L rule. So here we are using N plus L rule. Now, what is the N plus L rule? When N plus L value is lower, the orbital energy is lower. So, lower N plus L value, then lower energy of an orbital. Lower energy of an orbital. So, lower N plus L value, lower energy. Then, we may take if two orbital as same N plus L value. So, we are taking two orbital have same N plus L value. N plus L value. Then we are taking lower N value as lowest energy. Then lower N value have lowest energy. So, we may take that according to this, here we are taking 1s. Then, here what is the N plus L value? Here, what is it? Here 1, plus 0. Now, here azimuthal quantum number, we are taking that here for s orbital 0, p orbital it is 1, then d orbital it is 2, and f orbital it is 3. Then it is L values. Now, 1s, and here it is 2s and 2p. Now, comparing the 1s value, 1s here 1 plus 0, so that it is 1, n plus L value. And the n plus L value for 2s orbital, 2 plus 0, so that it is 2. So, it is 1 plus 0, so 1, and here it is 2 plus 0, it is 2, and for 2p orbital, and here it is 2 plus p orbital as 1, so L value is 1, so that it is 3. And we are taking that is 2p and that 3s. And for 3s orbital n plus L value, what is n plus L value? Here 3 plus 0, so that 3. Now we come 2p and 3s orbital. And what is the first rule? Lowest n plus L value as lower energy. So here 1s as lower energy, and after that 2s as lower energy. And comparing 2p and 3s, and here we are following the second rule, and if it has same n plus L value, consider lowest n value. And here n value is 2 and L value is 1. So totally n plus L value is 3. And here n value is 3 and L value is 0. So total 3. So n plus L values are same, then we are consider the lowest n value. Among these it is 2, after that 3. So first 2s orbital has lower energy than that of 3s. Then after the 3s, then it is 3p and 4s and 4p. Now compare 4s and that 3d. What is the n plus L value? Now for 4s orbital it is 4 plus 0, so that it is 4. And for 3d orbital, so it is 3 and it is d value, that is 2, so that it is 5. So 4s after that 3d, because n plus L value for 4s orbital is 4 and 3d orbital is 5. And so that it is 4s, 3d, 4p. And after that it is 5s and 4d and 5p. And after that 6s, 4f, 5d and 6p and 7s. So anywhere we may compare. Whenever we are comparing, we are following this true rule. What is that? Lowest n plus L value as lowest energy. And if two orbital have same n plus L value, then we may consider lowest n value as lowest energy. Suppose we may consider 5p and 6s. What is the n plus L value? Here it is 5 plus 1, then it is 6. And here 6 plus 0, so that it is 6. So that here both are same n plus L value, but among these we are taking that the lowest n value. So here 5 and that 6, so that 5p orbital has lowest energy than that of 6s. So according to this, we may write the energies of orbital. Now we are taking ground state and excited state. Consider hydrogen atom. And the electronic configuration of hydrogen as one electron. So the one electron occupying the first energy orbital, that is 1s1. Now we are taking that here it is a hydrogen. It is a hydrogen and it has one electron. Now here the one electron is occupies in 1s orbital. 1s orbital. So the electronic configuration is 1s1. Now it is a ground state because it occupies the lowest energy level at a normal state. Now that is 2s, it is 2p orbital, this is 2p orbital are unoccupied. Now what will happen? It is the energy level, so it is lowest energy level and the highest energy level. Now the electron absorbs energy externally and get excited. So it is a ground state. So in a ground state, the electron present in that 1s orbital. Now energy is absorbed. So some amount of energy is absorbed by the electron and it get excited. So what will happen? Here we are taking the energy and it is 1s orbital and here it is 2s and that it is 2p. Now 1s orbital electron absorbs energy and get excited, then it will occupy the 2s orbital, so that it is known as excited state. Excited state. After absorbing energy, the electron present in the highest energy orbital, which is known as excited state. Now we may take the concepts of degenerate orbital. So it is degenerate orbital. What is it? Degeneracy or degenerate orbital. Now we may take that in a multi-electron system we may compare, that is p orbital. P orbital. It has 3 orbital, one is px and py and the pz. So in a space it has 3 orientation and all the 3 px, py and pz orbital have same energy. Then it is known as, that is a degenerate orbital. So all px, py, pz have same energy, so that the p orbital has same energy. So same energy orbital are called as degenerate orbital. Degenerate orbital. And here the degeneracy is lost in presence of electric field and magnetic field. So in presence of electric field and magnetic field, the degeneracy is lost. So the degeneracy is lost. So same or equal energy orbital are called as degenerate orbital. Then in presence of electric field or magnetic field, the degeneracy is lost. And the next one we are taking, that is effective nuclear charge. Effective nuclear charge. And what is effective nuclear charge? Suppose if you are taking the multi-electron system. In multi-electron system, the forces of attraction between the nucleus and the electron is present. So, if we are adding an electron, that is a multi-electron system, there is a existence of repulsive forces among the electron. So, here it is always the electrostatic forces of attraction is present. So, electrostatic force of attraction between nucleus and electron. nucleus and electron. So, it is always present in an atom, that is, the electrons are bound by the nucleus by electrostatic forces of attraction, because electrons are negative charge and nucleus is a positive charge. And in a multi-electron system, what will happen? There is a existence of repulsive forces. Existence of repulsive forces. Repulsive forces. So there is a existence of repulsive forces among the electron. So electron repulsion is present in among the electron. Effective nuclear charge is nothing but the net charge experienced by the electron after the repulsive forces is known as effective nuclear charge. So, it is a net charge experienced by the electron after the repulsive forces. So, after repulsive force, then it is known as effective nuclear charge. Now, here the effective nuclear charge depends shape and azimuthal quantum number. So, the effective nuclear charge depends, one, it is a shape of an orbital, and it is azimuthal quantum number. That is azimuthal quantum number. That is L. And here the effective nuclear charge decreases when the L value is increases. So, the effective nuclear charge decreases when the L value, that is azimuthal quantum number, increases. Azimuthal quantum number increases. So, we are taking the effective nuclear charge of orbital that is S orbital as greater effective nuclear charge than that of P and D and F, and it is the order effective nuclear charge. And so what will happen? Hence the energy of orbital. So energies of orbital is in the reverse order, S as lowest energy than that of P and D and that F in a same energy level. In same energy level. That is, what is that? In a same energy level. Suppose we are taking that fourth level. And in that fourth level, 4s as lesser energy than that of 4p and 4d and that 4f. So 4s as lesser energy than that of 4p, 4d and 4f. Now, if you are taking the effective nuclear charge increases, the stability is also increases. So, effective nuclear charge increases, stability increases. So the energy is decreases. So we may consider the same orbital of a different atom is considered, suppose 2s orbital of hydrogen, lithium, sodium, potassium is considered. Now, the same orbital of a different element is considered which one has lowest energy, which one has highest energy, depending on atomic number. So, energy of a same orbital decreases with the increase in atomic number. So, energy of same orbital decreases with increasing atomic number. Increasing atomic number. So atomic number increases in the case of hydrogen, lithium, sodium, potassium. So hydrogen 2s orbital has lesser energy than that of lithium 2s orbital, and that is sodium 2s orbital and potassium 2s orbital. Filling of electron in orbital follows three rules. The first one, it is Aufbau principle. Aufbau principle. What is that Aufbau principle? Aufbau is a German word, so it is the German word and which means building up. So it is building up. Electrons are arranged in increasing order of energy level. Is nothing but Aufbau principle. So electrons are arranged in increasing order of energy level. Then it is known as Aufbau principle. Now we may take here Aufbau principle. It is now we may arrange the order of energy level according to this. First 1s, after that 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and 4d, 5p, 6s likewise. So it is 1s as lowest energy orbital. So electron occupies the lowest energy orbital. After completing the lowest energy orbital, electrons are filled the next higher energy orbital. So first electrons are filled up with 1s. After that it is 2s. After that 2p, 3s. So likewise 1s and 2s and 2p and 3s and 3p, then it is 4s and 3d and 4p, and it is 5s and 4d and 5p, and it is 6s and 4f, and it is 5d and that 6p. After that it is 7s. Now we may take after that 4s it is 3d. So 4s, after that 3d, after that 4p, 5s. 5s, then it is 4d. So after that 5s it is 4d, 5p like this. Then it is Aufbau principle. Pauli's exclusion principle. Pauli's exclusion principle. Now, Pauli's exclusion principle states no two electrons can have same sets of all four quantum numbers. So, it states no two electrons can have same sets of all the four quantum number. All the four quantum number. So, you know that the quantum number, what are the quantum number? The quantum number are N, L, M and that S. That is principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. And for an orbital, no two electron can have same sets of all four quantum numbers. For example, we are taking helium nuclei. It is helium nuclei. And in the case of helium nuclei, there are two electrons. So its electronic configuration 1s2. So it is 1s2. Now we are taking the first electron. For first electron, we are taking that the quantum numbers. So it is first electron. First electron quantum number n is equal to, it is 1s, so that 1. And here L value depends on n value, so that n minus 1 L values are possible, so that it is 0. And m value is 0 and s value is plus half. So it is, that is clockwise rotation, so that the spin quantum number is plus half. If you have taken the second electron, we are taking the second electron and the same n value is 1 and L value is 0 and m value is 0, then s value is minus half. So according to Pauli's exclusion principle, no two electron can have same sets of all the four quantum number. They are same sets of n, L and m. They will be differ in spin quantum number. So the spin quantum number is differ between these two electrons. So otherwise, Pauli's exclusion principle is state that the orbital has only two electrons with the opposite spin. It is also Pauli's exclusion principle. Next, the third rule, it is the Hund's rule. Hund's rule states the electron do not start pairing until all those orbitals are singly occupied. So Hund's rule is nothing but electron do not start pairing, until all those electrons in degenerate orbital are singly occupied. So if you consider the degenerate orbital, so we are taking an example, that is oxygen, the atomic number 8, and its electronic configuration is 1s2, 2s2 and 2p4. And among these, which one is degenerate orbital? P orbital as degenerate orbital. So that here it is 1s2 and it is 2s2 and we are considered that is 2p orbital. And these three orbitals are equal energy. They are called as degenerate orbital. Now, what will happen? We may fill up with that 4 electron. Now, that is first singlet, after that doublet. It is nothing but Hund's rule. First, we may fill up with a singlet and after that doublet. So, we are fill up in 1 and 1 and that 1. After that, it will be pair. So, electron do not start pairing until all those orbitals are singly occupied. So, it is correct. If you are fill up in like this, suppose here 1, 2, 1, 2 and here pairing starts before it is singly occupied. So, it is here wrong according to Hund's rule. So, while you are writing the electronic configuration, we may follow these 3 rules. One is Aufbau principle and second one Pauli's exclusion principle and the third one it is Hund's rule. Thank you.